everyone, welcome back to another video. So in this video, we're going to be going over direct versus inverse proportion. So let's define a few things first, right? So let's look at the formulas. Before we even get into what each formula means, we have to understand what the variables are in the equation. So our first variables are x and y. Well, those are actually an ordered pair from a coordinate plane. So or as ordered pair. And K is known as the constant proportionality. So let's go over the brief definition of constant of proportionality, right? So the constant of proportionality is a ratio. So a ratio between a ratio as in a slope, right? So a slope in a linear equation are all examples of constant of proportionality. Essentially, what constant of proportionality is it's a common ratio that both y and x follow, right? So say you have a value, say you have a table, x and y table, make it a bit bigger. So you have your x value to be 1, your y value will be 2. Say your x value is 2, your y value will be 4. If it's, say, 3, then 6, 4, 8, so on, so forth. Notice how no matter what, the ratio between y and x is always 2. So your constant of proportionality here is 2. And say you wanted to write a function demonstrating the constant of proportionality, or the function to find y in terms of x, you know that 2 times your x value gives you this table, right? But what essentially is happening here is 2, or your k value, is your slope. So now let's get into what is going on here, right? So a direct variation is essentially a linear function with no y-intercept, with a y-intercept of 0, 0, right? So this is key. And let's get into defining it, right? So what this is basically saying here is that the ratio between these, or y and k, x times k will always give you y, right? That's essentially what's happening here. So say, let's think of an example where you would use direct variation. So an example is hours worked, right? To wage earned. Say you're in a babysitting job, and per hour you work, 1 hour gives you $7, right? So say that's that. Then what happens if I work 3 hours? What money will I get? Or say, what if I earned $56? How many hours did I work, right? You know that there's a set proportion. So your formula for this scenario would be, say hours worked is equal to your x variable, right? And wage earned is equal to your y value. So there's a direct proportionality where the hours worked or say X is equal to your wage is equal to 7 times, okay, the number of hours you worked times 7 gives you the total number of money you earned. So using this equation, you can find how many hours you worked here, which is 8, and you would have to work you would get $21 from working 3 hours, right? So now let's think about inverse proportion, right? What this one is it's a rational function. I'll be doing a video on rational functions later on, but it's important to understand that inverse functions actually look a little something like this, with there being asymptotes, right? So an example where you would use inverse variation would actually be something like, say, the question will actually tell you if it's inverse or direct proportion, but let's see what applications of inverse would be. Okay, inverse. So inverse variation is actually used as one quantity increases while the other one decreases. Some examples would be the atmospheric pressure, or because as altitude increases, air pressure decreases, or say some gas relationships, so on and so forth, right? So that's where inverse variation would be used. So what we can see here is these two are very different, but use the same variables, especially the graph. I actually drew the graph flipped. It's technically supposed to be something like this to be more real. Because as you can see, as one quantity increases, or if the X quantity increases, the Y value decreases. And as the X value decreases, the Y value increases, right? So that's how you know. And here with direct variation, either your graph is always increasing, or your graph is always decreasing. Either way, it's going to cross at 0, 0. I didn't draw it perfectly, but let's assume that this is 0, 0, right? And it's either always increasing or always decreasing. So now let's get into solving some word problems, right? So say we have a situation where Johnny or Jahi works or actually, you know what? Let's not do a work problem. Let's say we have X varies directly with Y, and has a constant when the K value, or the constant of proportionality, is equal to 2. So the question will be, find an equation and find the value of X when Y is equal to 6, right? So let's take a minute to try this on your own, please. And once you're done, just come back and let's look at the solution. Okay, so assuming you paused and did it, let's break down the question, right? So we know that the constant of proportionality is 2, and we know that it's a direct variation. That's the two most important pieces. So now let's take a look at the formula for direct variation, right? So we saw it was Y is equal to K times X, linear equation with a Y-intercept of 0, 0, right? So here we know that the K value is equal to 2. So our equation is 2x. So that's the solution to the first part of the question here. Now let's take a look at the second part of the equation, right? So we know that here 6 is equal to k times x, right? We can just plug in this equation for the right-hand side. So we get 6 is equal to 2x. Divide by 2 on both sides, and we get 3 is equal to x. That's our solution. So our solution set, or our answers, would be, so the first part, y is equal to 2x. To the second question, x is equal to 3. So now let's look at another problem, right? Say we have x varies inversely with y. And say when x is equal to 2, then y is equal to 3. And when x is equal to 1, y is equal to 6. So our questions are then going to be, find an equation that models the solution or models this scenario. And then it's going to be find the constant of proportionality, obviously, and then it's going to be find the value of k, or sorry, my bad. Find the value of x when, say, let's make this fun, y is equal to -4. Yeah. Okay. So first, let's find our equation, right? So what we know is that the equation to solve inverse proportion is, or the value is, k is equal to x times y, right? So say we have this. Let's plug in the values here. Let's plug in situation 1, right? Oops, that's really thick. But okay, k is equal to 2 times 3, which is equal to 6. Let's make sure that that's correct with the second case. K is equal to 1 times 6, which is equal to 6. Voila. So we know our k value, the k value is equal to 6. Now we need to find an equation. So really, since the only constant here is k, our equation would just be 6 is equal to x times y, right? Now let's finally address the last part of the equation, which is find x when y is equal to -4. So what we're going to do here is we're going to take the equation that we made and we're going to plug in some values here, right? So say we have 6, then we're going to take -4 times x, right? And now what we're going to do is we're just going to solve it like a normal equation. We're going to divide both sides by -4. We're going to get -6/4, which is equal to x, which is equal to -3/2, which is the simplified form. So here we have our solution as x is equal to -3/2. Plugging it in just to double check gives us the correct answer. And this question actually does a really good job of highlighting how you can have two sides to a rational function, right? So here, when we have 6 is equal to y/x, as rough graph, not to proportion at all, but this just models how you can have negative and positive values. And notice how the quadrant, the point here that we found of -3/2 comma -4 is only in the third quadrant. And notice that our first point that we saw, including these 2 points, are only in the first quadrant and the third quadrant. So that just illustrates how a rational function works in relation to a graph and how they're quadrant, they're sectionalized. And this is essentially how to solve inverse variation and direct variation questions. If you have any feedback, suggestions, etc., and questions related to this topic, please feel free to put them in the comments and to email me. So thank you so much and have a great day. Bye.